Hello, welcome to Electronics Education. This is Vincent Chang. In this lecture, I'm going to continue the lesson on how to solve a practical amplifier, part 2, step-by-step tutorial. Based on the lesson we learned from the previous lecture, this is part 2. Based on the part 1, for practical series-shunt feedback. It seems very complicated at first sight, but we have a strategy to tackle this. What's our strategy? Reduction, simplification. And then here's the outcome. Evolution of reduction. Here's the outcome of reduction. Here's the outcome of simplification. Because we have successfully reduced a complicated practical case into an ideal structure. But when you really solve a circuit, let me finish this. Because when you reduce, what's the purpose? Because we already reduced to the ideal structure. They are equivalent to each other. They are equivalent to each other. Then you can just boldly adopt the formula you learn, we developed from the ideal case in the practical situation for the RIF, ROF, and the AVF. For input resistance, output resistance, and the closed loop voltage gain. So in reality, when you solve a circuit, here's the step-by-step. Once you identify a feedback topology, series shunt, shunt series. Once you identify the topology, follow 3 steps. Number 1, sketch. That's your responsibility. The A circuit. The A circuit. Italic A, all right? It's italic A. A circuit, the open loop gain circuit. Then calculate beta. And plug in the ideal formula because you reduce to ideal structure. The first step, in a feedback circuit, you try to sketch the A circuit, the open loop gain circuit. Sketch the A circuit. Basically, don't touch the basic amplifier. You just duplicate. Don't touch inside. Just duplicate the basic amplifier. And then call the RS. Come in. And then call on the load resistance, come on in. So call in the RS and call in the RL. Then you kind of, as a beginner, as a no-brainer. And then you have to add 2 resistors. One is called RA, the other one is called RB. Why? Why you include? Why we take the RS. Of course, electrically equivalent, right? I explained this in the previous lecture. RB, RL. But why RA, RB? Why AB? From where? If you go back to if you have this question, if you cannot answer this question, that means you don't really understand the essence, the key concept from the previous lecture. So previous lecture is the foundation. So I encourage you to go back. And then you will find out where is the hometown of for the I and RB. I use the word hometown. Feedback network. So why you add these 2 resistance, RA and RB? Because you want to take the loading effect into account. What loading effect? The effect of loading from the feedback network upon the basic amplifier. You want to consider the loading effect. All right? Therefore, so that is your job to find out the RA and the RB. What is RA? It's defined by the H11. What is H11? H11 defined by V1, look at the equation, divided by I1 and set V2 is 0. What do we mean by V2 is 0? You have to short circuit the feedback network, the output of the feedback network. You have to short circuit. Pay attention to what I emphasize, all right? You have to short circuit the output of the feedback network and looking the input and looking from the left and take the input resistance of the feedback network when the output is set to 0. When the output is short circuit, then that's the value for RA. That's the loading effect at the input side. What about RB? RB coming from is defined by the 1 over H22. 1 over H22. So here's the H22. Look at the equation. I2 over V2 set I1 equals 0. All right? So output RB represents the output resistance. But when the input is what? It's open. When the input is open, you get it? So you open the input of the feedback network and take the output resistance of the feedback network. That's RB. Once you sketched a circuit and you try to calculate the VO over the VI, what is VO? The VO, the right, the one on the right, VO over VI. That's A. Once you get A, the next job is to get beta. It sounds easy, right? But sometimes it's not. According to my experience, it's not. It's not that easy. It's not that easy. You can just going around every topology, find out this is what's the beta for shunt series. It's not. It's not. So you need a strong foundation. That's why you have learned from the previous lecture. What is beta? Remember, I said the meaning of the 4H is the is the input resistance, 1, a reverse voltage gain, a forward, what? Current gain, and output conductors. So reverse. So think about this. Reverse. So it's the reverse. H12. Input, reverse, forward, and output. 1, 1, 1, 2, 2, 1, 2, 2, matrix. Reverse. V1 over V2 set I1 equals 0. V1 on the left hand side, V2 on the right hand side. Okay? And set I1 is 0. So you have to break the input. You have to open circuit the input and to send out a V and send in a generator, a voltage generator V2 from the right, and then try to measure the. If you send a testing voltage from the right and try to measure the output voltage, and the ratio tells you the beta. That's the beta. Once you get beta, then move on to the step 3. Because you have A, you have beta, you have amount of feedback. That's it. Then you can just plug in the result. You can just plug in the result. For the series shunt, the ideal case, you just plug in the result. I explained this in the previous. Here's the result. In the previous lecture. Right? Here's the result. Here's the takeaway. So remember this. Remember this. Your job is, I just try to make it easy for you. Okay? 3 steps. A, beta, then ideal. Then plug in. A, beta, and then plug in. Let's see. It sounds very easy, right? Let's see if you can really tackle a case. I'm going to show you another example in the next lecture video. Let's try to apply this to a case. This is the end of the lecture. Thanks for watching.